Alright, this is information about the section 1.4 notes. So the first part of the notes is talking about polynomial equations. We're going to be talking about equations that have multiple exponents or higher exponents, such as x cubed, x to the fourth power, and higher powers than that. We're also going to talk about some of them that have exponents that are rational exponents, so they'll be fractions. So the first thing we talk about is factoring cubics. So this is something that you should have seen before. Some of you may have also seen the term SOAP, same, opposite, always positive, which is a way of remembering the signs for your cubic problems. So I have a cubic problem up here, x cubed minus 8. This is a cubic problem because x can be written as x cubed and 8 can be written as 2 cubed. So the a value would be x and the b value would be 3. And so if I replace it into this problem, a comes first, then b, then a squared, then ab, then b squared. And so I end up with the x and the 3, the x squared, the 3x, and the 9. And then the first sign is always the same as what I started with. The second sign is always the opposite, and the third sign is always positive. So these are just factoring the cubics. Now if I wanted to set this equal to 0, then that's going to change my problem, and I'll show you an example of that in a minute. Here's another one. So my cubic is 27x cubed plus 64. So 27 can be written as 3 cubed, x cubed, and then the 4 can be written as 4 cubed. So a is 3x, b is 4. So here, you got to remember, if I take 3x and I square it, I get 9x squared. And then a times b would be 3x times 4. And then b squared. The first sign is the same as I started with. The second one is the opposite. And the third one's always positive. So now here's some other factoring problems. So this one has to be factored using a method called grouping. So a clue to that is that you have 4 terms. So with grouping, you have to take the first 2 terms and the last 2 terms, and you have to do your greatest common factor. So for the first 2 terms, I have x squared in common, so therefore I'm left with x plus 3 when I factor that out. The second thing that I'm going to say is always bring down that negative, or the sign that's in the middle. So it's going to be negative 4 factored out, which means this is x plus 3. So our goal is to have these 2 parentheses be the same. If they're not, then you may have factored wrong, or it might not factor by grouping. So then I can put my x squared minus 4's together. The x plus 3 factors out, and it's still equal to 0. X plus 4 is what we call a difference of square problem, so that can factor into x plus 2 and x minus 2. This is x plus 3. So all this is equal to 0, and then I can find each 0 by setting each part equal to 0. And so my 3 zeros are negative 2, positive 2, and negative 3. Now on this next one, again, if I factor by grouping, I can factor out the x cubed, and I've got the x cubed and then x plus 3, and here I can factor out the negative 8. Again, we want to bring down that sign, so that's where we get the negative 8, and then that's going to be x plus 3. And then I can take out the x cubed minus 8 and the x plus 3, and then x cubed minus 8. We did a similar problem, or actually we did the same problem up here. X cubed minus 8 factors into this. Oops, I made a mistake up here. This should be 2, this should be 2, and this should be 2, and this should be 4. Sorry, made a mistake. Okay, so, whoops, you didn't see my mistake. Okay, so that should be 2, that should be 2, that should be 2, and that should be 4. Sorry. So I did that same problem up at the top. So x cubed minus 8 factors into x minus 2 and x plus 2x plus 4. Did it again. And so then I can solve each part of the problem. So this becomes 2, this becomes negative 3, And then I have to do quadratic formula times A times C. So this is wrong. So this is going to be 4 minus 16, which is negative 12. Okay, and then that's going to factor, sorry, this is all wrong. So this is going to factor into negative 2 plus or minus 2i square root of 3 over 2. And then all the 2's can reduce, so I get negative 1 plus or minus I square root of 3. Sorry. Okay, so rational expressions or rational equations. This is not rational equations. Rational equations are fractions. So they are equations that involve fractions. So we're looking at rational equations involving fractions. And we're going to be talking about domain of problems. And domain is just simply the x values that we're allowed to have in a problem. So with domain, my x values are restricted with fractions. Okay, because with fractions I can have no 0 in the denominator. And I'm also restricted with square roots, because with square roots you cannot have negatives. Now, I can have negatives, but then my answers are not going to be real solutions. So we're looking for our problems to have real solutions. Okay? So here we're asking you to find the restrictions on the domain. So when you look at the domain of these problems, you have to remember that you cannot have 0 in the denominator. So x plus 3 cannot equal 0, so x cannot equal negative 3. And on this one, x minus 1 cannot equal 0, so x cannot equal positive 1. So those are my restrictions on the domain. That means that I have to make sure that my final answer don't have those solutions. Okay? Here's another one. Again, I can factor this and I can say x squared minus 1 is the same thing as x plus 1 and x minus 1. And so that means x cannot equal 1 and x cannot equal negative 1. Here, I'm going to say 2x minus 3 equals 0, and I'm going to solve that. So x cannot equal 3 halves. Okay, so that's where I got my restrictions on my domain there. So then you have to make sure that when you get your final answers that you look at those restrictions and eliminate answers. Okay? So the next two examples, I've got them worked out on this paper one way, and I'm going to show you another way to work them out that may be a little bit easier. So what we're going to do is we're going to take this problem and we're going to rewrite it. So we're going to have x, I'll move this down a second. Okay, so we're going to take this problem and we're going to treat it like our common denominators. And I'm going to multiply both sides by x minus 5 over 1. So on this side, the x minus 5's are going to cancel out. I'm just left with x. On this part, I have to distribute. So I'm going to get 1 over 1 times x minus 5 over 1. So this is going to end up being 1 times x minus 5. And then for the second part, I've got 5 over x minus 5 times x minus 5 over 1. And I'm left with a 5. And then if I continue on and I combine like terms, you'll notice that my x's cancel out, and I'm left with 0 equals negative 10. And that tells me that there's no solution to this problem. Okay? So we're going to do the same thing on the next problem. And on the next problem, let me write this down. All right, so on the next problem, if I do the same thing, I'm going to multiply both sides by x plus 3 over 1. And so then what happens is I end up with 3x times x plus 3 over 1 minus the x plus 3's cancel out here, and I'm left with x plus 2. I've got to put my parentheses there. And then I end up with 4x plus 13 here. So working this out, this is what I end up with. And this is a quadratic problem. So once I've combined like terms, I end up with 3x squared plus 4x minus 15. And this will factor, and then I can set both of my factors equal to 0. And I end up with negative 3 and 5/3. Well, if we look back at the beginning, my restriction on my domain is that x cannot equal negative 3 because of the denominator. So down here where I got negative 3 as a solution, I have to throw that out, and it's extraneous. All right, so let me see if that helps, and I'll get the rest of part 4 up there.